Alright, so I'm just going to show a little bit of what I got here. This right here is the video display that I've been working on. I've made a number of changes to it. It is not in its final state right now, unfortunately. As I did make a lot of changes right here, right specifically to this red portion. What this kind of is with all these crazy blocks, it looks really cool. It is pretty cool, actually, as when you send a signal, it will see how it moves those blocks out of the way, which is pretty awesome. And you can see it goes down the line. What this would do is essentially, if I put a signal over here somewhere, right? Say, let's just say I want to drop a signal in over here. Well, let's not actually drop the toggle switch, but let's just say I want to put a switch in right here, right? Now let's say I want to send a signal in both directions, it will do that. So essentially what happens, see, notice those blocks go down there and move, and also down the line. So the signal can be passed in anywhere down the line and go in both directions. So that's basically what this is a two-directional bus, or I guess if you want to call it a duplex, or half duplex. I don't know how you would, I guess duplex, yeah, it would be duplex because it goes both ways. Anyways, but effectively the problem is you got to have these pistons, right? So essentially here you notice these pistons move, which is really cool. The problem, if you notice, is that as you go down the line, you can kind of see it here, but it takes time for those pistons down the line to fire. So basically you'll notice that there is a propagation delay as it goes through each repeater here. And that's not really what we want. So that's problematic for obvious reasons in a computer. This is a really cool design, but again, I can't really, it's not going to work. It's not going to be very practical for what it is, for what I need to do with it in a computer. So unfortunately, that's going to need to go, basically, need to get redesigned. But yeah, it is cool though. So anyways, basically what happens here is each of these layers, right, we've got 16 layers, and each of these layers goes to one of the layers on the display, right? So that's why, as you see here, the red layers, that's where all the data goes, right? So the data actually feeds the display itself. But basically each of these stacks, right, is addressable. So essentially, each of these lines here, right, goes to specifically to one stack, which is now so wide, right? So right about here somewhere, and then this one, well, this one goes like here somewhere, and then from here to here somewhere, and then, you know, basically like that. And so each of these is basically one layer, one block of the stack, right? And it goes back like 32 or 16 or whatever. I think it's 16 right now. So that's that whole display. It's very, I should not have made it this wide starting out. I should have gotten the whole display together before going to that length, those lengths, but you know, it is what it is. So basically, yeah, that's the addressing layers there. We would feed data in from the front. I don't have a way to do that directly, although right here, right? So let's say I want to send data on that layer right there, right? Well, that's address 1, right? So I really want block 1 to be fed right here. So let's just say I want 1. So we should already have, in fact, 1 is encoded onto the on the address channel, address line down here. Well, that would be 1 over, I guess, because 0 would be the first one. So that'd be like over here somewhere, right? Boom. So if we hit commit, I believe that's going to actually send our commit signal, which I don't know if we're doing that right now. I might have changed other stuff. I don't know if we can, maybe we're not there yet, because I think I made some other changes, and yeah, I used to have it working, although basically it's not right now. So yeah, all that for nothing really, but let's see. Yeah, basically the data comes in here. Let's see if we can send the right signal. We can't because this isn't allowing a signal in. Why isn't it allowing a signal in? Because that's locked. But let's see, the second one isn't locked, right? All the other ones are locked. so this one isn't locked. Oh. So why isn't the signal coming in here? Let's just test that, right? So let's just say we wanted to test a signal, right? Boom. We should technically be able to get a signal in here on, let's say, oh, right, because we don't have a way to do that. Okay, that's interesting. Let's just go ahead and do that. It's probably just because I never got there. Boom. Okay, now, oh yeah, it does work. So there it is. It's right there. If I wanted to turn that off, it's not so hard to do. Let's go ahead and actually turn the signal off. And there it is. It's now off. It just writes it really. It allows the signal right through because there's no commit in this point. Well, it's actually already committing. If I go ahead and turn this off, it probably will lock that in place. So even if I change up here now, you'll see that that really shouldn't change. Let's just see if that's still the case. And yep, see, so it does stay in place. So it doesn't commit. Essentially, this signal is locked in place. Even though there's no signal here, you can see that that commit line does what it needs to do. The same thing happens with the addressing down below. So all of this addressing is the same kind of deal. So let's say I want to instead commit a 1 onto the next 2. So that'll now go over there somewhere, right? And if I say commit it, now, of course, not really, hold on, because we didn't actually set the bit up here. You gotta set the bit. And we gotta remember that I probably didn't wire these all up either. Did I? No, I didn't. So, if 4, right? So, let's just say I've got the address, the correct address, if I remember. This is, of course, 1, and this is 2. So 2 and 1 should be 3, which should be counting from here should be 0, 1, 2, 3. Should be this one. So let's go ahead and wire this up, and then let's go ahead and make sure, because the bit needs to get set into there. So now we need to actually just go ahead and recommit it down here, and now we should see it pop up there. Sorry, this wasn't quite ready, but let's go ahead and do it. And of course not, because why, right? Let's just go ahead, since we got, oh, there it is, it made it. So now you see, yep. So again, if you go over here, you'll see this line that's fed is exactly to right here that we just wired up, right? Or it was, yeah. So yeah, I mean, basically some of these are wired, some of them aren't, probably because I copied certain things and I didn't. Other ones weren't wired when I copied it. So yeah, like every other one was wired. But basically, that's what it is. It's almost there. But again, this isn't going to really work for me because it's too slow. These pistons don't really do. They're just too slow by design. So yeah, I mean, it's a cool design, but it won't. It basically won't be what I need, unfortunately, for a full-fledged working computer. But it's still really cool. So yeah, there you have it, and we're going to send the commit signal, turn that one off, and yeah, that's the basic operation as it is right now of the display logic that I came up with, and boom, we will uncommit that, right, and we should see that go off whenever it makes it that far, which, let's just go ahead and see. I think it has to be set as right down there. Let's go ahead and see. I'm not sure why it didn't turn off the top one, which is a good question. Oh, because we don't have it addressed, maybe? I don't know. That's a good question. Let's see. Oh, because the second bit is still addressed. So this would technically be byte 1, which would be right here. So we turn this off, and then we recommit, which will turn that off, which should already be set to commit, so it should just turn that off, I think. There we go, made it. So yeah, it's not the fastest, but again, that's basically what it does. So yeah, pretty cool.